Hey guys, my name is Pawan Belagatti, and today's talk is all about building rack systems using LlamaIndex. I'm going to show you through a simple tutorial how we can basically build simple retrieval augmented generation applications for systems using this framework, AI framework, LlamaIndex. Let's get started. This is the agenda. We're going to talk about building AI applications, how complex this journey is, and we'll talk about large language models. We will talk about chatbots using LLMs. We will talk about the introduction of LlamaIndex, the growth of LlamaIndex, components of LlamaIndex, LlamaIndex workflow, a simple workflow, and we will also talk about RAG, retrieval augmented generation, the concept. We will also talk about where does LlamaIndex fit in the Genai dev stack, and we will talk about how to get started with LlamaIndex. And at the end, I have a simple demo to show you guys how we can basically build RAG systems, simple RAG systems using LlamaIndex. So that's it. So let's get started. So we all know that building AI applications is a very complex journey, right? Connecting multiple data sources, feeding the data, creating index. There are a lot of integrations that are required, and basically building the AI applications is a very complex and multifaceted process that involves um, many people and a lot of effort is required. And since it has a lot of these steps like data collection, data pre-processing, data cleaning, and also when it comes to model training, there's not many things that need to be taken care of. So each requiring a specialized knowledge and effort, and additionally ensuring models performance. Evaluation, deployment, and monitoring, all these things basically add up extra layer of challenges, and that also demand a lot of effort and skills, expertise. And also we see that there is a lot of skills gap in the industry these days. So this particular slide is for you to know that building AI applications is kind of a complex journey, right? So are LLMs just enough to build AI applications then? Right? It's actually not. LLMs are just one piece of the puzzle, as you can see in the image, right? There are other things that need to be taken care of, like the data management when it comes to data ingestion, data processing, vector storage, connection, integration, infrastructure management, integration layer, application logic. So all these things are basically required to build robust AI application, but LLMs are just a piece of the puzzle, basically, and you need more than just large language models, to build robust AI applications. Then what about chatbots using LLMs, right? So these are all basic chatbots, which are the output is predefined by the AI engineers, data engineers, basically. And all these chatbot basically face several challenges and limitations, like they are restricted to their training data and cutoff date, and they can't basically verify the accuracy of their own responses, and they lack access to the real-time or custom data if you want to, right? And they can't integrate with business systems or any logic. You can't do API calling and all that because these are just chatbots using LLM models, right? So LLMs are basically not just enough, right, to build a robust AI application that can think, reason, and generate responses. So what exactly we require then, right? That is where we require an AI framework like LlamaIndex, where LlamaIndex basically sits in between the basic LLM chatbot and the integrated AI application. It comes as a savior to help you with real-time data access, verified responses. You can do response verification, and you can connect your own custom data. So custom knowledge integration, you can do business rules enforcement, and you can do a lot of things and basically build very robust AI applications using this framework known as Llama Index. Okay. So let's talk about Llama Index, previously known as GPT Index. Um, it's an innovative data framework, especially designed to support LLM powered applications, and where you can basically use your own data ingest and build custom applications around your own data. So there are basically two parts: Llama Cloud, which basically takes care of the index through various integrations, various partners, as you can see in the image. And Llama Index is the open source part platform that basically orchestrates everything. Like you can do search, you can create chatbot applications, and all that. So that's about the Llama Index. And if you go to Google Trends and see the growth of this word, keyword Llama Index, it's up and growing. So this is the interest over time. Google Trends actually talks about the interest over time for a particular keyword. I just went ahead and searched for this keyword Llama Index, and it is growing up and above. Why not? Because most of the companies now want to become an AI company, and since LlamaIndex is one of the robust AI framework out there to build AI applications, many people are interested to, individuals and companies are interested to search about it and learn about it and to build applications using LlamaIndex. And this is the growth of LlamaIndex on GitHub. The star history, it's just going up and up, right? And what exactly, why the name Llama Index, right? Why, if you take the literal meaning of Llama Index, you can basically split this word into two parts, that is Llama and Index. Llama, as you can see, it's self-explanatory. It basically associated with carrying large loads, right? Symbolizing the ability to store and access large amount of data, as this Llama is doing here in the left-hand side. And with index part, it refers to the structured way of organizing data for efficient retrieval. That's why Llama Index is basically used in your uh, RAG applications. We will see what is RAG in the upcoming slide. So, hope you understood the literal meaning of Llama Index. Why the name Llama Index, right? And it's basically a data framework for LLM applications, Llama Index. So one thing that needs to be taken care while using Llama Index is, or any while building any LLM application is, any LLM app is only as good as your data. So right, if you put any like garbage in, the garbage out, the garbage only comes out. So good quality, the data quality is very important in building AI applications or RAG applications. So good data quality is necessary component of any production LLM application, as you can see here, right? The raw data, data processing, and clean data, and then with that you can build production ready LLM applications like Q&A chatbot, Copilot, autonomous agents, and structured extraction and all that. So these are some of the components of Llama Index: document loaders, nodes, indices, query engine, storage context. So just like LangChain has different modules, Llama Index also comes up with all these components to help you build robust AI applications. So what are document loaders? Basically, that will help you to ingest data from various sources, PDF, web pages, APIs, and all that. Notes are nothing but, like, notes break down documents into smaller, manageable chunks that can be processed effectively. Indices organizes and structures the data chunks for efficient retrieval and querying. Right? And query engine is basically processes user queries and generates the relevant responses using the indexed data and LLM. And storage context is manages the persistence of data, indices, and embeddings for future use. So you all these things like document loaders, query engine, storage context, all these things are required to build a robust AI application. So this is a simple Llama Index workflow. There is a uh, um, there's a document which gets loaded, which gets passed, and it gets indexed, and it's stored in a vector store, like a vector database. And then when a query comes in, it goes through the vector store to find. Even the query gets converted into a vector embedding, and it goes through the vector store to find the relevant chunk and to answer back to the user. That's the response that we see. All right. So this is a detailed view of LlamaIndex workflow actually, right? Structured, unstructured sources. You can basically feed in index any type of data, structured, unstructured data. And then Llama Hub is one more thing where you can find a lot of connectors, third-party community maintained connectors or integrations from LlamaIndex. So you can find a lot of data connectors, and your data gets chunked, and then the nodes are created. Finer, the minute details about your document, apart from the chunks, and all these and the embeddings are created, and all these embeddings are stored in a vector database, indexed and stored in a vector database. And for any user query, it goes through the router, and then it goes through the retriever again to find the relevant chunk from the vector store. And finally, it goes through an LLM model to formulate the answer back to the user. So at different stages of this whole pipeline, LlamaIndex basically provides different modules or components, as we can see, right? There are data connectors, there are nodes, there are indexes, there are LLM models, right? All these things are provided by LlamaIndex. So since our demo or the tutorial is all about how to do retrieval augmented generation using LlamaIndex, it is very important to understand what is RAG, retrieval augmented generation, right? So what happens usually, large language models hallucinate. If you ask recent like recent event, if you ask a query about any recent event, for example, who bought SSV Jaiswal in the IPL 2025 or 2024, the LLMs cannot answer that the real time the answer. So sometimes they might answer. They can come up with some fake answers, made up answers. So this behavior of LLMs is known as hallucinating behavior. And to reduce this hallucinating behavior, we basically have three important approaches. One is prompt engineering, where you basically um, experiment with your prompts. It's an art and science of working with your prompts. And then the second approach is fine tuning, where you take a base model and you train that base model with your custom data so that it understands your language and grammar, and so that you can use it for your use case. And then the third one is basically RAG, what we are seeing now, retrieval augmented generation, where you basically give the model an external database custom source so that the LLM can go and fetch the relevant answers from there. So RAG was introduced as a component concept in 2020. It is a research paper published by Meta AI, where researchers led by Patrick Lewis proposed the idea of combining a retrieval mechanism with a generative language model to enhance the accuracy and contextuality of generated text by accessing external knowledge sources. So here you augment the system with an external knowledge source so that LLM cannot hallucinate or come up with a fake answer. It can actually go there to the connected external knowledge source to find the relevant answer. That's how you basically build um, contextually relevant responses, and that's how RAG stands as one of the prominent approaches to reduce the LLM hallucination. Okay, so here also you can see the same, right? Sorry. There is a pre-processing phase where the documents get split into chunks, and um, that's how vector embeddings are created. Each chunk is assigned with a numerical value. That's how vector embeddings are created, and all these vector embeddings are stored in a vector store. That's about the pre-processing phase, and then the inference runtime is when the question from a user comes in, and even that question gets converted into a vector embedding, which goes through the vector store to find the relevant chunks. And then everything, all the context relevant chunks go through the LLM model to formulate the final answer back to the user. So that's how the RAG basically works. So that's about RAG. We understood a lot about RAG. So why RAG is required to build contextually relevant, to give contextually relevant responses back to the user. As you can see here, right? If you ask a question, who won the 2024 Nobel Prize in Literature? The pre-trained large language model will come and say, hey, as of my last update, I can't provide information about who won the Nobel Prize in Literature. But if you give the same system an external database, a source where the LLM can go and fetch the relevant chunks and responses, then it can actually answer back with the RAG setup saying, hey, the winner of 2024 Nobel Prize in Literature is Han Kang. So that's the importance of RAG. And LlamaIndex RAG pipeline, there is a data ingestion happening, there is a document processing, index construction, query processing, and the response generation happening. We just saw how um, RAG pipeline basically works. So data first enters through various document loaders that handle diverse formats. It can be PDF, web pages, databases, different sources, right? So this content then moves to document processing, where it's intelligently gets chunked. There are different chunking methods that you can use according to your use case, and then these chunks are transformed into vector embeddings, right? The machine can understand. So, and this vector embeddings are stored in a vector store or vector database, what you call. And when a user query arrives, it undergoes processing where it's embedded and potentially broken into sub queries for complex questions. And finally, in response generation, LlamaIndex combines the relevant context from the vector store with the LLM capabilities, and there's also vector search comes in to find the um, to find the relevant chunks, and it goes through an LLM model at the end to formulate the answer and formulate the answer and respond back to the user. So where does actually LlamaIndex fit in the GenAI dev stack? So this is a simple GenAI dev stack I have created. So you see at the front about there is a front end hosting where your Vercel, Netlify, Streamlit, all these things come together, and LlamaIndex is where it fits in the runtime or the framework layer, and then comes the vectors databases layer where you see your SingleStore, Pinecone, VV8, Chroma, Quadrant, all these vector databases come into the picture. And then comes the foundation models, right? That's where your OpenAI, Anthropic, Cohere, Meta, Mr. All these models come in. And then the infrastructure layer is where all the big guys, NVIDIA, AWS, Google, and all these guys come there. So getting started with Llama Index is kind of very easy. I'm more of a Python guy, so I use pip install Llama Index. And this is a simple getting started guide with Llama Index. You can put some documents in the folder called data, then ask questions about them. So this is the default code from Llama Index. From Llama Index, you import vector store index, simple directory reader, and then you basically mention the documents, and then you index them, and then there is a query engine, and then the response generation, and then it basically at the end it prints the response back to the user. So the same thing is explained here, right? What is vector store index? What is simple directory reader? I'm going to share the link so that you can go through and study this. So RAG using LlamaIndex, we have a CSV file, and it goes through um, it gets chunked, and then That's how each chunk is assigned with a numerical value, and that's how vector embeddings are created. And all these vector embeddings are stored in a vector store. You can select your vector store, can be single store, chroma, milvus, and all that. And then when a user query comes in, even that gets converted into vector embedding, and finally it goes through the vector store using vector search methodology, semantic search approach to find the matched docs or matched relevant chunk. And at the end, it all goes through the LLM model to finally answer, respond back to the user. So we're going to see a simple demo or hands-on now. So I'm using SingleStore as my vector database. So you can create a free account using this link, or you can just go to singlestore.com, create a free account. Um, because we are going to get we're going to get publicly available link, and it can be PDF or CSV file as we saw, and we're going to chunk that and create embeddings of that file, and then store in our vector database. Okay, create vector embeddings and store all these vector embeddings in our vector database, and we are using single store as a vector database. So let's see how we can simply create a RAG system using LlamaIndex, right? So since we are using SingleStore as the vector database to hold all our data vector embeddings, so you need to create a free account on SingleStore. SingleStore has free share tier. You can use it for free until you run out of your credits. So go to singlestore.com, or you can use the link that that you saw in the previous slide. So once you sign up and sign in, this is where you land. You can create a workspace for yourself, and creating a workspace is very easy. Just create a workspace, and yeah, I mean, you can select, you can name your workspace, and then attaching your workspace, you can create a database. So creating a database is also very easy. I have my database created, workspace, and my database is already, it's all ready. And one more interesting thing about Single Story is it has integrated notebooks feature. As you can see, you can go to Data Studio, and then you can create a new notebook here, right? You can do it shared, you can do it personal, give it a name. So I have already created my notebook. So this is the notebook, a RAG with LlamaIndex. Hope you created your workspace and the database is ready. So come here. Let's get started with installing the required libraries. We'll install, of course, LlamaIndex, and then SingleStore DB also we install, and then the LlamaIndex vector store SingleStore DB, and then we're also going to install OpenAI from LlamaIndex, and then we'll import the libraries, required libraries, and we'll set our API keys, right? OpenAI API key and the SingleStore DB URL. And then we'll download and save the PDF. So what we can do is, this is the PDF that I have. Right? This is some publicly available PDF. It's about economic report. Okay, we'll give it a name, and then we'll download it. PDF downloaded successfully to this, um, and then we'll initialize single store vector store. This is the thing, and we're gonna give a table name. This is the table name, content field, metadata field, and the vector field. And then we'll mention the embedding model and the required settings. So we're gonna basically use model GPT-4, right? And then the temperature is zero point 0.1, load and process the document, right? We're gonna load and process the document. When you do that, say number of documents loaded 178, first document content preview 2023, world economic situation and prospects. So that is the title of that document. Create and persist the index. So that's what we are doing here. And then function to query the index. So now we can chat with the PDF with our queries, right? So these are the queries. What are the main economic challenges discussed in the report? What are the key recommendations for policymakers? What about the microchip supply, The microchip supply shortage is predicted to raise or fall down. So these are some of the questions queries, which our system using LlamaIndex, it's basically going to fetch all the relevant answers from the PDF that we gave. Our PDF already got chunked and vector embeddings are created and everything is stored in our vector database, right? So once you use these queries, you run this particular code, you can see the responses, right? Query is this, and the response is the main economic challenge discussed in the report include tight labor markets in the developed economies, blah, blah, blah. And this is the query, and this is the response for the query and response. So this is the exact response and the response from the PDF that we have loaded. So that's it. This is how you can basically create a simple RAG workflow using LlamaIndex. I'm going to share the code. I think this is the code. I'm going to share the link of this so that you can go and just see um, how to create simple RAG system using LlamaIndex. Right. Thanks.